All right, mathematicians, we are simplifying square roots today. The square root of 50. I'm going to show you two different methods, and you can choose whichever one makes more sense to you. And some of you may want to have both of these methods in your toolbox. We got the square root of 50. Now, 50 is not a perfect square. Think about your perfect squares. 1 squared is 1. 1 is a perfect square, although it's not very often that it'll be useful. 2 squared is 4. 4 is a perfect square. 3 squared is 9. 9 is a perfect square. And so we continue. 16 is a perfect square. 25 is a perfect square. 36 is a perfect square. If you'll go all the way to 12 squared, I think those are all really helpful to have memorized as perfect squares. So 81 is a perfect square, and 100 is a perfect square. 121 is a perfect square, and 12 squared, 144 is perfect square. So these are all perfect squares. So if I were you, I'd make a list and try to memorize those perfect squares. So as we're looking at 50, which of these is a perfect square factor of 50? So we don't have to look at any of the ones above 50. We can look at the ones below 50. If you divide 50 by 49, you don't get a whole number, you get a decimal. Same thing with 36, but when you do 50 divided by 25, you get 2. So we could rewrite this as square root of 25 times 2. You can even write it this way if you like. Square root of 25 is 5 because 5 times 5 is 25, and so we get 5 square root 2. So that's the perfect square factor way. The other way is called a factor tree. Write your number that's underneath the radical, and then think of any two numbers that you multiply to get that number. We do not want to use 1 in that number, so any others. So you might think of 5 times 10. And then the 5 is prime, so we'll stop on the 5, but on the 10 we can keep going. We can say 5 times 2 is 10. Now, the ends of the factor tree is what makes up your prime factorization. We got 2 factors of 5 and a factor of 2. So instead of writing the square root of 50, we can now write the square root of 5 times 2. Now you're going to look for pairs of the same number. We've got a pair of 5s here, pairs of the same factor. And so the square root of 5 times 5 is 5. And then the 2 is still left underneath it. One little thing I teach my students, just kind of helpful. In order to square dance, you need a partner. And so these 5s have a partner. So they can square dance. We can take the square root of 5 times 5 and get 5. So whichever of these methods you prefer is fine. This one in particular, I would say, is a lot easier if you think about your perfect squares. 100 is a perfect square. 100 times 2 gives us 200. The square root of 100 is 10. That's going to be quite a bit quicker than doing a factor tree, but we'll run through that anyways. You still might think of 2 times 100. Maybe on 100 you think of 10 and 10. On 10, 5 and 2, 5 and 2. So the prime factorization here is 2 factors of 5 and 1, 2, 3 factors of 2. We can take the square root of 5 times 5. We get 5. We can take the square root of 2 times 2, and we get 2. And the other 2 is left underneath the radical. So in front of the square root, we have 5 times 2. That's 10. 10 square root 2. So if you recognize the perfect square factor, this way it's going to be less writing and probably quicker. If you don't recognize that, the nice thing about the factor tree is you can think of any two numbers that multiply to get that. So some people might have started with 20 and 10, and you just keep on going until you get to prime numbers. Let's look at this one, 80 and, so let's look at the factor tree there. So I would probably think of 8 and 10 for 8, 4, and 2. For 4, 2, and 2. And then for the 10 over here, 5 and 2. So we have 1, 2, 3, 4 factors of 2. And then we have this factor of 5. You're looking for pairs of the same number. So we've got square root of 2 times 2, that's 2. Those can square dance. Square root of 2 times 2 is 2. Those can square dance. And then this 5 is left underneath the radical. In front of the radical, we have 2 times 2, that's 4. So 4 square root 5. Perfect square factor way, going from 80, you would have to recognize that 16 times 5 is 80. Square root of 16 is 4, so 4 square root 5. A little bit harder to pick out 16 as perfect square factor, so the factor tree might have been a little bit easier on that one. Hopefully this is helping you on your math learning path.